All right, so let's finish up the assignment. Sorry about number 5. When I first did it, I knew the answer and I was using that in the equation. So number 5, going back to what we said we know, unit circle means the radius is equal to 1. And so I know this point right here is at 1, 0, and then all the way around the circle, 0, 1. This point here would be negative 1, 0. And then down here at the bottom, 0, negative 1. And so the point on the unit circle with an x coordinate of 4/5, so if I go 4/5 of the way here, I'm just estimating, okay, it's going to be up here at this point, the x value is 4/5, and then drop it down. This point, the x value is also 4/5. And so we can do some work now for part B to figure out the y value. Because once again, the points on the unit circle has a radius of 1. So I know the hypotenuse of this right triangle is equal to 1. I know the x value, this leg right here, is equal to 4/5. And so I can figure out the y value using the Pythagorean theorem. So we know y squared plus 4/5 squared is equal to 1 squared. And so y squared plus, we can evaluate 4/5 squared on the calculator. So parentheses 4 divided by 5, and then close the parentheses and square, and you get 0.64. And 1 squared is 1. So that means that y squared is equal to 1 minus 0.64, and that is where the 0.36 comes from. 0.64, 1 minus 0.64, 0.36. And so then y is equal to the square root of that, which is, so the square root of 0.36 is 0.6. And then that as a fraction is 3/5. Okay, so I know the length of y is 3/5, but in this quadrant, y is positive, so the other coordinate is 3/5 for y. But in this quadrant, y is negative, so in this spot point here, the y is negative 3/5. All right. Number 6, the point 815 lies on a circle centered at 0, 0. Where does the circle intersect the x-axis? Where does the circle intersect the y-axis? Explain how you know. So if we think about a circle, and the center of the circle is at 0, 0. If this is the radius of the circle, then this point right here will be at whatever the radius is, and then 0 for y. This point up here will be at 0 for x, and then the radius for y. Okay, and then the other two places where it intersects the x-axis would be at the negative radius value, 0, and then this one here, 0, and the negative radius value for y. So if the point is at 8, 15, I'm just kind of going to make up the coordinates there, then this length here is the radius. So if this is 8 and this is 15, that makes this the point 8, 15. And so we can figure out the radius of the circle using the Pythagorean theorem. So I know r squared right here is equal to 8 squared plus 15 squared. I'm going to find that on the calculator. So 8 squared plus 15 squared is 289. And so r is equal to the square root of 289, and that is 17. Okay, so the radius of the circle is 17. And so thinking about how we label these as the, use in reference to the radius, it will intersect the x-axis when x is 17 and y is 0. Also when x is negative 17 and y is 0. So that's those 2 points. And then it will intersect the y-axis here and here when x is 0, y is 17, and when x is 0, y is negative 17. So those 2 points. All right, finally, number 7. Those 2 triangles are similar, so then y is the tangent of A, this angle here, equal to the tangent of D, this angle here. Well, one thing we know is that in similar triangles, their angles are congruent, and so those will be corresponding angles. So the angles are congruent, and the tangents of the angles are also congruent. But we can actually prove this a little bit more. So thinking about angle A, tangent is opposite over adjacent. So if I know the tangent of angle A is equal to A over B, and then the tangent of angle D, opposite over adjacent. So the tangent of angle D is equal to D over E. And I think about, well, what does it mean to have similar triangles? It means that the sides of the triangle have been scaled by a factor. And so what that means is that side D and side A, they correspond to each other. So the measure of side D is equal to the side A times some scale factor. I'm just going to call it R. And then the same is true for E and its corresponding side B. So E is equal to B times some scale factor R. So if I take these expressions for D and E and replace them in this ratio, if D is equal to A times R and E is equal to B times R, and then those R's would cancel each other out, this is equal to A over B. So the tangent of A is equal to A over B, and the tangent of D is, through some logical thinking, also equal to A over B. That's it. Have a great day.